Okay, so this video is on feedbacks. The last video we looked at a simple system made up of a reservoir with a pump pumping water into it, and we looked at the residence time of water in that jug, and we calculated it by looking at the volume of the reservoir divided by the flow in or the flow out, which are equal at steady state. During that video, we closed the valve a little bit, and in response to closing the valve, the reservoir volume increased. It went from 4 liters up to 6 liters, despite the fact that the flow in didn't change, right? And so at steady state with 4 liters, the residence time is 2 minutes. At steady state with 6 liters, the residence time was 3 minutes, okay? There's a feedback, though, in that system that allowed it to achieve a steady state despite having closed the valve a little bit. And that feedback in this case is really gravity and hydraulic pressure. And so pressure forces the water out through that valve, and the amount of water sitting in there is controlling the pressure, right? And so as the volume increases, water's forced out through the valve more rapidly, all right? And so that is an example of a feedback. And in this case, it's a negative feedback because it tends to stabilize the system. As volume increases, flow out also increases, stabilizing the system to a new steady state. There are a lot of examples of feedbacks in the Earth system and just generally kind of in the world around us. A good example is a thermostat and an air conditioner. So as the temperature in a room increases, the thermostat recognizes that. It turns on the air conditioner, which cools the room off, lowering the temperature and turning off the air conditioner until the room warms up again, when the thermostat turns the air conditioner back on, further lowering the temperature back to the set point. So it stabilizes the system. It's a negative feedback. Negative feedbacks tend to dampen change in a system. That is in stark contrast to a positive feedback. Okay, and so a good example of positive feedback is water vapor in the atmosphere. And so as global temperature rises, as we learned, the amount of water vapor that can be held in air increases. And since water is a powerful greenhouse gas, the greenhouse effect increases, which causes the temperature to go up further. That warmer air can hold more water, increasing the greenhouse effect and leading to further increases in temperature. So this is a positive feedback. The higher the temperature gets, the more water can be held by the air, increasing the greenhouse effect and continuing to make the system warmer. And so positive feedbacks tend to drive systems away from equilibrium or amplify changes to the system in response to an initial perturbation. Okay, and so there are a variety of feedbacks in the Earth system that we talked about. We talked about the albedo feedback associated with ice cover. So ice is very reflective, and so as glaciers expand and cover more of the Earth's surface, more of the sun's radiation is reflected instead of being absorbed by the Earth, and that lowers global temperature, which further allows ice sheets to expand, increasing the global albedo and lowering global temperature. Ice sheets expand, more energy is reflected, temperature goes down even further, right? So that's a positive feedback in the Earth system. There are also lots of negative feedbacks in the Earth system. We talked about silicate weathering as sort of the ultimate negative feedback that governs long-term climate and long-term temperature on the Earth, having kept us within this really quite narrow range from 0 to 100 degrees C, and really quite narrower than that over the entirety of Earth's history. And so planetary habitability is really directly related to the presence of these negative feedbacks and their persistence through time. And so feedbacks are a critical part of system science and really understanding the Earth as a system and how all of these components relate to one another and how changing one part affects the rest of the system. It's all about feedbacks.